Here it's going to be design and implementation of data warehouse using Spark and Deltalake or data tables, and using S3 as object storage or Minio for open source, because we are going to run this on a local system. You can find this repository on the description of this video. First, I'm going to walk through how we can set the delta tables on Spark session. You can find it here on these command files and on the repository. I'm going to use a bunch of Bitcoin file data in order to run initial loading, updating or observing data, and also some files in order to get update and check whether the delta are going to update the data or delete the data also. Yeah, we're going to see it later. As you can see, we need to set all these files here. Let's go check on Minio. Minio, as you can see, is an open source and object storage. It has very nice features. It can scale horizontally very nicely. You can create bucket here. Each bucket we can set replication if you have multiple servers. We can create users. We have Hive and Spark with read and write access. You can see the policy for each user. It's really awesome. It's really cool. So here's the data tables and data lake bucket, and this is the raw data. And after running, and it is going to be a delta table here, and it's a Bitcoin data table. Let's walk through the coding. After setting the Spark session and configuring the Minio access key and secret key, we are having a Spark SQL extension IO delta. We need to set this. Also, in order to create Hive table, we need to enable Hive support. This is some transformation on data files, and I'm not going to write to MariaDB. So this is the initial load. We set the Hive and Minio. In order to make this container up and running, we just run this command here. So we create a Spark session and we set the address to the initial load data. It's going to be here, not here, here. Initial load data here, and the output path is going to be the delta table and Bitcoin. By running this, it will create a delta format file and on that path. So the delta file is going to be created very easily, and let's check it out here. This is the delta table. As we can see, partition by date time. You can see in the code, partition by DS, date stamp. It has delta lags in order to any changes that can be here. It's very cool. And also we are going to discuss about this Simulink format. After creating the raw data lake, and we need to create the tables. Here's the Spark app. It's the same. Create an external table, Hive Bitcoin. By creating this external table, we can run Presto query on top of these delta files, which is very cool. You can run run it and create the tables. Also, these commands are in the documentation of Deltalake. You can check it out later. And also we need to create an internal delta table in order to run direct query using only Spark without Presto or anything. We create this table too. Just first, let's run it. I'm going to run Spark create table. At first it's going to download this package, because when we are importing delta tables, it needs this package to be installed, so it's going to run it and download it. And after creating these tables, we can run any query that we want on Delta Bitcoin. It's going to be very easy. We can update, or we can delete. These are just simple queries that we can run. We can also mention the delta tables by this command. We don't have to create the whole tables by the command that I show here. We can not run this command, and we can run the query on the delta tables by just mentioning this delta and the path of the delta table and that in the warehouse file storage we use here S3. So it's really cool and easy. This is a just sampling on how this query is going to be run, and just a demonstration, nothing more. In order to observe the data, we have this new data here. It's going to be a simple reading the data from that CSV. And here's the magic of delta tables that was very cool, because in the old-fashioned data warehousing using Hadoop and Hive and Parquet, we couldn't have update or observed or delete, but here we can see the delta table makes our life so much easier. We read the file from that path, and we have a unique identifier, just like timestamp here. When this match, it will update all. When it's not matched, it will insert all. It's quite easy and very cool. So this is an observed, and here I showed about. So this is our Spark working with that. I need to mention that these jar files also have to be added to the directory, and by using these -- jars. In the next, I'm going to run just some Presto. I need to stop some containers I'm not going to use. Here I'm going to create Presto cluster. And run some Presto CLI. Let me show about in order to run Presto on Hive and Deltalake, we need to create these Hive properties. Here you can see that we mentioned meta store. Also we mentioned the S3 path for the data object storage or data warehouse or data lake. This is the access and secret key. So here is catalog is going to be Hive, and by running this command it will Presto CLI and catalog Hive. I can just run show tables. If you run distributed query, and can check it out on Presto CLI here. There was just initial, I don't know why. So this is the finished, yeah. Here you can see this is a query show tables. It will mention that this is a query on localhost 888. So let's just run a simple query. I'm going to use this. One of the beautiful feature of Presto is that it will cache the queries and make it very much faster at the next time it's the same query. It's really cool. So it might take some time in order to run this query at first time. It didn't find that data. Let's go for another data. This timestamp. The Presto going to run a distributed query on a Parquet file format. It's going to be run in Parquet file format. You can see here snappy format, snappy compressed, and Parquet file format. So let's check out the result of this query that we can see here. Yeah, it is the result of this query, which is pretty cool. How long it took? About too much. Let's run it again. It must result much faster this time. Yeah, this is much faster than the last time. So it only 32 millisecond, I think, and it's just 6 millisecond. It will cache the date, cache the results, so it won't run again. That's really cool for distributed running query and building dashboard on top of that. I really like Presto. So let's see the magic of Presto and superset together. It's going to take a little time to make the Presto up and running, so we'll wait. Up until then, let's check out the Minio. So as we can see, here's object storage. It's the Minio. This is the Deltalake bucket. There are many features in Minio. It's an open source, but you can use S3 or anything, any object storage for Delta tables. We can have many tables as we want. So we run these distributed query using Presto on top of these tables, and this format is built for in order to Hive tables and data tables. If they're going to be an Hive schema, an external Hive schema, this symlink format manifest should be created. You can follow the, I'm not going to deep right now. You can follow the documentation and just demonstration of this technology. Localhost ID. Yeah, the superset is up. Admin. Okay, there we go. Let's check what dataset do we have here. Yeah, we have Presto right here. Do we have dataset? Oh yeah, I have already built this stuff. So we can check out these data. Yeah, Hive Bitcoin. We can have preview of the data or run a query on top of that. It's pretty cool. Yeah, here this is a result of this query, and we can check that. Yeah, it's PyHive. Very awesome UI by Presto. What query that has been run on top of that? Really amazing, yeah. Also, let's check out about creating a dashboard or chart. Another word. I'm going to build simple chart, yeah. Or time series. Created a day. I'm not going to do it. No filter. Query. What query it should going to run? Bitcoin value. Average per day. Let's check it out. So it creates the data and it's only showing for Wednesday. That might be a little better. So we can see that these queries results are going to be here, and the second one run much more faster because Presto caches, and it's awesome, I think. And we create a dashboard with a chart and Bitcoin value. So in summary, we have bunch of raw data here in CSV. We run Spark initial loading and it creates these delta files, delta table directory, and we're running some external Hive table. We create some Hive table by the documentation that, and it's easily you can find it on the repository. So after creating this Hive table, we can connect it. Also, we can have update or delete using Spark that I have shown here. And we can update and delete. It's really easy. And here we create a a catalog using Presto in order to run outside of Spark, and it run outside of Spark and connected to superset, which is really cool, and create a dashboard. Yeah, we have, if imagine that you have a massive petabyte or 100,000 terabyte of data, and you store the data in compressed file and columnar store data and in a distributed and replicated kind of way and manner on a open source like Minio or S3. It's in scalable data warehousing, and it can run and using caching on Presto and create a dashboard on top of that. So it's amazing, it's very beautiful, and that's it. Yeah.